welcome back to my channel, SciSap. So today is another video dedicated to the series to learn about AWS and cloud computing. The topic of discussion for today is AWS Analytics, and we will be covering Athena, Cloud Search, Data Pipeline, EMR, which is Elastic Mapreduce, Glue, Kinesis, Lake Formation, QuickSight, and Redshift. I will try and go through at a very high level what each component is, but before I begin, I wanted to request that you like, subscribe, and comment on my video because it makes me feel so much happier and keeps me motivated. So let's get started with Athena. So what is Analytics Athena? I'm trying to open the page and my notes. So here goes. Athena is an interactive query service that makes it easy to analyze data directly in S3 using SQL. So it's a query service, and you can query your data directly from your buckets that you create, which is the object stores S3. With a few actions in the management console, you can point Athena at your data stored in S3 and begin using standard SQL to run ad hoc queries and get results in seconds. Athena is a serverless application, so there is no infrastructure to set up or manage, and you pay for only the queries you run. And Athena scales automatically, executing queries in parallel, so results are fast even with large data sets and complex queries. That's all you need to know for Athena. Now let's move on to Cloud Search. Cloud Search, it's a fully managed service in the cloud that makes it easy to set up, manage, and scale a search solution for your website or application. With Cloud Search, you can search large collections of data such as web pages, document files, forum posts, or product information. You can also quickly add search capabilities without having to become a search expert or worry about hardware provisioning, setup, maintenance. So as your volume of data and traffic fluctuates, Amazon Cloud Search scales to meet your needs. So the kind of searches that you can perform, Cloud Search first uses an index, and you can search both structured data and plain text. So Cloud Search can feature full text searches with language-specific text processing, Boolean searches, prefix searches, range searches, term boosting, faceting, highlighting, and autocomplete suggestions. You can search results in JSON or XML and filter results based on field venues and sort results alphabetically, numerically, and or according to custom expressions. So there are a few other details that I would like to elaborate on, but because we have some time constraints for the sake of this video, I will move on to the next component, the next resource, and I'll come back with more information in the next video. Now let's look at what is data pipeline. Data pipeline is a web service that you can use to automate the movement and transformation of data. With data pipeline, you can define data-driven workflows so that tasks can be dependent on the successful completion of previous tasks. So you define the parameters of your data transformation, and AWS data pipeline enforces the logic that you've set up. So you need to know a few other components that work very closely with data pipeline. So a pipeline definition specifies the business logic of your data management. And then a pipeline schedules and runs tasks by creating EC2 instances to perform defined work activities. And you upload your pipeline definition to the pipeline and then activate the pipeline. Then you can edit the pipeline definition for a running pipeline. This is very important, and activate the pipeline again for it to take effect. So you can deactivate the pipeline, modify a data source, and then activate the pipeline again. So when you're finished with your pipeline, you can delete it. It's a task runner pulls the tasks and then performs those tasks. So for example, task runner could copy log files to Amazon S3 and launch EMR, Elastic Mapreduce clusters, and we will touch base on EMR a little later. Task Runner is installed and can run automatically on resources created by your pipeline definition. So you can create a custom Task Runner application, or you can use a Task Runner application that is provided by Data Pipeline. So for example, let's look at, you have an EC2 instance, and then you have an S3 bucket, and you have an EMR. So the daily task is to copy the log files to your S3 bucket, and you can add that to your data pipeline. The weekly task is to launch data analysis into Amazon EMR, and that can also be added to your pipeline. So that's the function of a pipeline. It lets you automate the movement and transformation of data across AWS resources. Now to talk about EMR, Elastic Mapreduce. So Elastic Mapreduce has been compared with many other vendors available, such as Databricks, and how to integrate the two, what the advantages are, whether we should use EMR over Databricks. But those are videos that I will create once I give you a solid understanding of basic cloud knowledge. So an Amazon EMR is a managed cluster platform that simplifies running big data frameworks such as Apache Hadoop and Apache Spark on AWS to process and analyze vast amounts of data. So by using these frameworks and related open source projects such as Apache Hive and Pig, you can process data for analytics purposes and business intelligence workloads. Additionally, you can use EMR to transform and move large amounts of data into and out of your data stores and databases in AWS, such as Simple Storage Service S3 and DynamoDB. So let's go over the overview. You need to understand EMR works through clusters and nodes. So the central component of EMR is a cluster. A cluster is a collection of EC2 instances. So each instance in the cluster is called a node. So each node has a role within the cluster referred to as node type. So you have these EC2 instances, you couple them together, it's called a cluster. Each one is called a node, and every node has a type known as node type. So Amazon EMR also installs different software components on each node type, giving each node a role in the distributed application like an Apache Hadoop cluster. So there is a master node. In terms of node types, there are three types. So there's the master node, the core node, the task node. The master node is a node that manages the cluster by running software components to coordinate the distribution of data and tasks among other nodes for processing. So the master node tracks the status of your tasks and monitors the health of the cluster. So every cluster has a master node, and it's possible to create a single node cluster with only the master node. Then you have the core node, a node with software components that run tasks and store data in the Hadoop distributed file system known as HDFS. So on your cluster, there's a multi-node clusters have at least one core node. So then the third one is a task node, a node with software components that only runs tasks and does not store data in HDFS, which is Hadoop distributed file system. So think of EMR clusters like you have a master node, core nodes, and then maybe you will have like a task node all together, all interconnected. Now, to submit your work to a cluster, when you run a cluster on EMR, you have several options as to how you specify the work that needs to be done. You provide the entire definition of the work to be done in the functions that you specify as steps when you create a cluster. So this is typically done for clusters that process a set amount of data and then terminate when processing is complete. So create a long-running cluster and use the EMR console, the EMR API, the CLI to submit steps, which may contain one or more jobs. Then you create a cluster, connect it to the master node and other nodes as required using SSH, and then use the interface that the installed applications provide to perform tasks and submit queries, either scripted or interactively. Then you can process your data by submitting jobs directly to the applications. And now in terms of processing data, I will deep dive a little more, maybe run a lab with you. Hopefully that will help you better. But for now, let's move to the next resource. Amazon Kinesis. I'm sure this is another very well heard of resource in AWS. So Kinesis Video Streams is a fully managed AWS service that you can use to stream live video from devices to cloud or build applications for real-time video processing or batch-oriented video analytics. So Kinesis video streams isn't just storage for video data. You can use it to watch your video streams in real time as they are received in the cloud. So you can either monitor your live streams in Management Console or develop your own monitoring application that uses the Kinesis video streams API library to display live video. So you can use Kinesis video streams to capture massive amounts of live video data from millions of sources, including smartphones, security cameras, webcams, cameras embedded in cars, drones, other sources. You can also send non-video time serialized data such as audio data, thermal imagery, depth data, radar data, and more. So as live video streams from these sources into a Kinesis video stream, you can build applications that can access the data, which is the most cool. It's the coolest part for me. And you can do this frame by frame in real time for low latency processing. So Kinesis video streams is source agnostic. You can stream video from a computer webcam using the GStreamer library or from a camera from your network using RTSP. So you can also configure your Kinesis video stream to durably store media data for the specified retention period. So Kinesis video streams automatically stores this data and encrypts it at rest. So additionally, Kinesis video streams time indexes store data based on both the producer timestamps and ingestion timestamps. So they have both. So when something ingests timestamps and when you produce it, it has the timestamps. You can build applications that periodically batch process the video data, or you can create applications that require ad hoc access to historical data for different use cases. So that's at a high level what Kinesis is. There are many cool use cases for Kinesis that I really want to talk about, but that is not scheduled for this video. So let's start talking about CloudFormation. This is another very well heard of analytics tool. So the CloudFormation is a fully managed service that makes it easy for you to build, secure, and manage data lakes. Lake formation simplifies and automates many of the complex manual steps that are usually required to create data lakes. These steps include collecting, cleansing, moving, and cataloging data, and securely making that data available for analytics and machine learning. So you point lake formation at your data sources, and lake formation crawls those sources and moves the data into your S3 data lake. So data formation provides its own permissions model that augments the identity access management model. So this centrally defined permissions model enables fine-grained access to data stored in data lakes through a grant-revoke mechanism. So lake formation permissions are enforced at the table and columns level of the full portfolio of AWS Analytics and machine learning services, including Athena and Redshift. So Athena we already spoke about. Redshift is something we will talk about soon. So how it's integrated with Athena, when Athena users collect AWS Glue catalog in the query editor, they can query only the database's tables, columns on which they have lake formation permissions. For Glue and lake formation share the same data catalog for console operations such as viewing a list of tables and all API operations. Glue users can access only databases and tables on which they have lake formation permissions. So AWS Glue does not support lake formation column permissions. Now, in terms of EMR, like we discussed, lake formation permissions are enforced when Apache Spark applications are submitted using Apache Zeppelin or EMR notebooks. So in terms of setting up the permissions and integration, it's quite different than using IAM services. So this is one of the functions you cannot use IAM services with. Now let's talk about QuickSight, which is another very interesting tool to use because it helps you visualize. So QuickSight is a business analytics service you can use to build visualization, perform ad hoc analysis, and set business insights from your data. So it can automatically discover AWS data sources and also work with your data sources. So QuickSight enables organizations to scale to hundreds of thousands of users and delivers responsive performance by robust in-memory engine, which is known as SPICE. So QuickSight, you can do the following. You can get started quickly. You can sign in and choose a data source and create your first visualization in minutes. Access data from multiple sources. You can upload files, connect to data sources, or use your own external data sources. So you can either use AWS data sources or your own. You can take advantage of the dynamic visualizations that are offered. Smart visualizations are dynamically created based on fields that you select. You can get answers fast, generating fast interactive visualizations on large data sets. You can tell a story with your data in minutes. You can create your own dashboards and point-in-time visualizations, share insights, and collaborate with others. So that's what Amazon QuickSight is, just another business intelligence tool that helps you visualize and create dashboards. Now, Redshift, we discussed Redshift in databases, but Redshift can also be used in analytics capability in the cloud. So it's to reiterate, Redshift is a fully managed petabyte scale data warehouse service in the cloud, and it's a collection of computing sources called nodes, which are organized into groups called a cluster. So it falls back onto the nodes to form a cluster, and each cluster runs on a Redshift engine and contains one or more databases. So now I want to dedicate an entire video to only talk about Redshift, and that way it becomes a little bit easier. So at a high level, that's what Redshift is, and in terms of analytics, again, you can use this to push data to use with some of your other capabilities that are offered in analytics, such as maybe QuickSight, for example. Now let's touch base on what AWS Glue is. It's a very interesting terminology. So Glue is a fully managed ETL, which means extract, transform, and load. Is another topic I will deep dive in a later video, but extract, transform, and load service is used it's what Glue is used for, and it makes it simple and cost effective to categorize your data, clean it, enrich it, and move it reliably between various data sources. So AWS Glue consists of a central metadata repository known as Glue Data Catalog and an ETL engine that automatically generates Python as Scala code and flexible scheduler, and handles dependency resolution, job monitoring, and retries. Glue is, again, a serverless application, and there's no infrastructure to set up or manage. So when you use Glue console to discover data, transform it, and make it available for search and querying, the console calls the underlying services to orchestrate the work required to transform your data. So you can also use Glue API operations to interface with Glue services, edit, debug, test your Python or Scala, Apache, Spark ETL code using a familiar development environment. So the question is, when can I use Glue? You can use Glue to transform and move AWS cloud data into your data store. You can also load data from separate sources into your data warehouse for regular reporting and analysis. And by storing it in a data warehouse, you integrate information from different parts of your business and provide a common source of data for decision making. So Glue simplifies tasks when you are building a data warehouse, for example. So it discovers and catalogs metadata about your data, stores in a central catalog. You can process semi-structured data such as click streams or process logs. And then second, you can populate AWS Glue data catalog with table definitions from scheduled crawler programs. Crawlers call classifier logic to infer the schema, format, and data types of your data. This metadata is stored as tables in the Glue data catalog and used in authorizing process of your ETL jobs. So Glue can also help generate ETL scripts to transform, flatten, and enrich your data from source to target. It can also detect schema changes and adapts based on your preferences. In addition, it triggers your ETL jobs based on schedules or events. You can initiate jobs automatically to move your data into your data warehouse. Triggers can be used to create a dependency flow between the jobs. In addition, it can gathers runtime metrics to monitor the activities of your data warehouse. It handles errors and retries automatically, scales resources as needed to run your jobs. So you can use Glue when you run serverless queries against your S3 data lake. So Glue can catalog your S3 data, making it available for querying with Athena and Redshift Spectrum. So with crawlers, your metadata stays in sync with underlying data. And Athena and Redshift Spectrum can directly query your S3 data lake using the AWS Glue data catalog. So with Glue, you access and analyze data through one unified interface without loading it into multiple data silos. And that's one of the biggest advantages that I have seen where Glue is used. You can create event-driven ETL pipelines with Glue as well. You run your ETL jobs as soon as new data becomes available in S3 by invoking your AWS Glue ETL jobs from a Lambda function. You can also register this new data set in Glue data catalog as part of your ETL jobs. You can also use Glue to understand your data assets. You can store your data using various AWS services, and still maintain a unified view of data using the Glue data catalog. View the Glue data catalog to quickly search and discover the data sets that you own and maintain and relevant metadata in one central repository. So the data catalog, it serves in a drop-in replacement for any external Apache Hive metastores that you possibly could use. So in a nutshell, that's what Analytics offers. So these are components that you should be well acquainted with. I also suggest that you do the quick labs that they offer to go and just play around with your 1-year free account to see if you can create, for example, a data pipeline, or if you can query some data with